Let's analyze the cubic function f of x equals x cubed minus 3x plus 1 and find its real roots. Here's the graph of our cubic function. Notice it crosses the x-axis at 3 distinct points, indicating 3 real roots. First, let's prove that this equation has exactly 3 real roots. We start with our function f of x equals x cubed minus 3x plus 1. Taking the derivative, we get f prime of x equals 3x squared minus 3. Factoring, we get 3 times the quantity x minus 1 times x plus 1. Setting the derivative equal to 0, we find critical points at x equals negative 1 and x equals 1. The graph shows a local maximum at x equals negative 1 and a local minimum at x equals 1. Let's evaluate the function at these critical points. F of negative 1 equals negative 1 cubed minus 3 times negative 1 plus 1, which equals 3. F of 1 equals 1 cubed minus 3 times 1 plus 1, which equals negative 1. Since f of negative 1 is positive and f of 1 is negative, the intermediate value theorem guarantees roots in different intervals. Now let's check the behavior as x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. Therefore, there must be exactly one root in each interval, one before negative 1, one between negative 1 and one after 1. This proves that the equation has exactly 3 real roots. Now let's find which root lies between 0 and 1 and approximate it using Newton-Raphson method. First, let's verify that a root exists between 0 and 1. F of 0 equals 1, which is positive. F of 1 equals negative 1, which is negative. Since f of 0 is positive and f of 1 is negative, the intermediate value theorem confirms a root exists between 0 and 1. Now let's apply the Newton-Raphson method to approximate this root. The Newton-Raphson formula is xn plus 1 equals xn minus f of xn divided by f prime of xn. We start with initial guess x0 equals 0.5. First, calculate f of 0.5. This equals 0.125 minus 1.5 plus 1, which equals negative 0.375. Now calculate f prime of 0.5. This equals 3 times 0.25 minus 3, which equals negative 2.25. Now we can calculate x1 using the Newton-Raphson formula. This simplifies to 0.5 minus 0.375 divided by 2.25. 0.375 divided by 2.25 equals approximately 0.1667. Therefore, x1 equals approximately 0.33. This diagram shows the Newton-Raphson iteration. The tangent line at x0 equals 0.5 intersects the x-axis at our approximation x1 equals 0.33. Let's summarize our results. Part A. We proved the equation has exactly 3 real roots, using critical points and the intermediate value theorem. Part B. The root between 0 and 1 after one Newton-Raphson iteration starting at 0.5 is approximately 0.33.